Hello everyone, I am Professor S.R. Patil, Department of Information Science and Engineering, PLD CET, Vijaypura. In today's class, I am going to teach you what are recursive functions and a brief introduction about storage class, which comes under in Module 4. So we'll start with this particular concept, that is a recursive function. So what do you mean by recursive function? A function that calls itself to do a specific task is called it as a recursive function. Remember this, a function that call itself to do specific task is called recursive function. The recursive functions are used by programmers to solve those problems in which the next action or calculation that depends upon the previous result. So when we use this recursive function, the recursive function that are used by the programmer to solve those problems in which the next action or calculation that depends upon the previous result. So in that case, we make use of the recursive function. So these are some of the uses of recursive function. So we'll see example to find the factorial of n by using the recursive function. You know what do you mean by factorial? 2 factorial, that is 2. How? 2 into 1, that is 2. 4 factorial, 4 into 3 into 2 into 1. How much? 24, right? Okay. So similarly 5 factorial, 5 into 4 into 3 into 2 into 1. Okay. So that is a factorial how you can going to calculate. So listen, this is a header file. Okay. So this is long int fact int x is there. Okay. So fact is nothing but it is a function name. Long int is it is a return type. Okay. We have seen the data types. So in the integer there is 3 classification: normal int, short int, and long int. Okay. So int x is what? Int x is a parameter or a argument which we have passed to the function name fact. So this is what we call it as a function declaration. So what is this function declaration? We have declared before the main function. So this is void main. Program execution always start from the void main function. Okay. So int n, the variable which I am going to use, I have declared in this part, that is n variable. Long int answer. Okay, long int is it is a data type. So answer, whatever the answer which I am going to get after performing the factorial operation, I am going to store in this particular variable answer. Okay. So clear screen. Enter a number. Okay. So which number, for which number I need to calculate a factorial. So that number I am supposed to read. How I can read that? I am reading that number using the scanf statement. Okay. Ampersand 10. So imagine that I have entered number 4. Okay. Here just check it out the output. Enter a number. I have entered 4 here. Okay. So for this number 4, I need to find the factorial. Okay, how I can do that? Next, answer is equal to fact n is there. So fact n, this is nothing but a function call. Fact is a function name, n is a parameter which I have passed. So here I have passed only one argument because I am finding the factorial of one number. Okay, so I have passed as a parameter as one number, 1. When I call this function, okay, what it does, the control automatically go to the factorial function. So this is a factorial function of return type long int, and I have passed the parameter int n. Okay, listen, if n is equal to 0, or this is a or symbol. Okay, if n is equal to 0 or n is equal to 1, then what it must return? It should return 1. Why? Because the 0 factorial value will be 1 only. Okay, 1 factorial 1 will answer will be 1 only. That is why if either these two cases, okay, so the result will be 1. That is why I'm going to return 1. Okay, else what it returns? It returns n into fact of n minus 1. What is the value of n? N is equal to 4. Okay, into, again I need to find the factorial of n minus 1. N minus 1 is nothing but 4 minus 1, 3. Okay, again n 4 into 3, again fact of n minus 1, that is 4 into 3 into 2 into 1. So what is the value? 4 into 3, 12, 12 into 2, 24, 24 into 1, 24. Okay, that is a result. Factorial is what? 24. Understood? Okay. Move on to the next concept, that is storage classes used in C programming. What are the storage classes which are used? Okay, that we can see later. Before that, we can see what are the storage class or a storage variable. The lifetime or visibility or accessibility of a variable used in the function depends upon storage class of the variable. Okay, the storage class are classified into following four types. How many types are there? Four types. What are those? Automatic or local or private variable, global or public variable, static variable, and register variable. So these are the four classification of the storage classes. So we'll see one by one. What is the first one? Automatic, and we can also be call it as a local variable. Okay, normally we call it as local variable, global variable. Okay, so here automatic variable can also be called local variable. Okay, what are the local variable, or we can say what are the automatic variable? So these are defined inside the functions and their lifetime is local to the function in which it has been defined. So it means that when I have defined this particular automatic variable, that lifetime of that variable will be local to the function. Okay, so by default all the variables are of type automatic only. Okay, so these variables are also called as local, I have told you, or internal variables also. Okay, so these, the auto keyword, which keyword we are going to use? Auto. The auto keyword can be used to define automatic variable. Okay, so from this we have understood that local variables are what? The lifetime of that local variable is local to the particular function in which it has been defined. Okay, so we'll see one example. So this is a simple example of automatic variables. This is a header file. Here I have the two functions. How many functions I have? Two. What are the two functions? One is f1, another one is f2. Okay, total I have two functions. So these two functions, it doesn't return any value, and programmer is not going to pass any parameter to these two functions. Okay, so execution of the program always start from main. Then we have used the variable x and we have declared here. Okay, and sorry, initialize also. Okay, so what is the value of x here? So value of x is 7. Okay, so this is what? Automatic variable or local variable. So this variable is, the lifetime of this variable is defined only for this main function. Remember this. Okay, so f1 and f2, we are calling the two functions here. This is a function call f1 and this is another function called f2. When I call this function f1, the control automatically go to the void f1 function. So what it does here, I have another variable that is int x that is assigned to the 17. So this is local to this particular function. Remember this. So as I told you, this variable is local to void main. Okay, and this x is equal to 17. This is local to the f1 function. Okay, so when I print this, I'm going to print the value that is x is equal to 17. Just look at the output. So x is equal to 17. I'm going to print. Then when I call the f2 function, the control automatically goes to the f2 function. So in f2 function, I have declared and initialized the value of x to the 177. So this is local variable. So it means that 177 I have initialized to this x variable. So when this particular x variable, the lifetime of this will be inside this function. Which function? F2 function. Okay, so when I print this, I'm going to display the x value, that is 177. Okay, listen, after performing these two functions, finally I am going to print the value of x, which is declared and initialized within the main function. Okay, so what is the value of x here? 7. So finally I am going to print 7 as a x value. Understood? So from this program we got to know that, so whenever I declare or I initialize a variable in that particular function, the lifetime of that will be that particular local to the function in which it has been defined. Understood? Okay. The second classification, that is global variable, or we can also call it as a public variable. So these are defined outside the functions. Okay, remember this. These are defined outside the functions and their lifetime is entire C program, including main and other user defined functions as well. But local variable, that particular function only, that lifetime will be, it has been defined. But here the global variable, it is defined outside and lifetime is entire C program, including the main and other user defined functions as well. Okay, so these are used to share data between many functions in a C program. So these are also called as global or public or external variable. Local variable called internal variable and global variables are called external variable. Okay, we'll see one example for this. So this is a header file. I have initialized this variable, declare and initialize this particular X variable globally. It means that this is a global variable. So this X value can be used in wide main function and it can also be used in the f1 function. Okay, both the function, we'll see. So this is a wide main. Okay, I'm incrementing the value of X by 1. Okay, initially what is the value of X? X is equal to 0. Even though this X variable we have declared globally, that can be used within the main function. So when I have the increment operation, the X value becomes 1. Okay, so what I'm going to print? X is equal to 1. Okay, look at the output. Now X value is 1. Okay, after displaying this, I am calling the function f1. It should end with semicolon. F1 function. Okay, so before printing the f1 function, I am supposed to go to the f1 function. So this is a f1 user defined function. So here also I am incrementing the value of X. So what is the initial value of X? X is equal to 0. Okay, so this is, I have declared globally. I can use it in this function as well. So I am incrementing value by again 1. So here once I have incremented in the main program. Okay, so once I incremented means before it was 0, once I increment the value becomes 1. Okay, so the value becomes 1. Before calling the function, value was 1. Understood? X value was 1. When I call this function, again I'm incrementing. When I incrementing again, the value of X becomes 2 because before it was 1. Okay, so the value of X will be 2. Understood? Okay. The third classification, that is static variable. Okay, so what are the static variable? So these are visible with the function in which they are defined and entire C program. So these are defined inside the function with the keyword static. Okay, we are going to use the keyword static. Once these variables become active, then entire C program, they go on updating. This is very important. Once these variables become active, then entire C program, they go on updating. So we'll see one example, you will get to know. Header file I'm supposed to mention here. This is a function prototype. Test is a function name. It doesn't return any value and it is not going to pass like any parameter. Okay, program execution always start from main. I have declared here. Okay, for I is equal to 1, I less than or equal to 3, I plus plus. Okay, so inside this I am calling the test function. When I call this test function, immediately control go to the test function. Okay, so even though I am not passing any parameter, it will perform some specific task. So we'll see what are the tasks. Static, we have used the word what? Static int X is equal to 0. So this is what? Static variable. So what is the value of X here? 0. Okay, so I'm incrementing X value by 1. Okay, so I'm going to display the value 1. Okay, what I'm going to display? 1. X is equal to 1. Okay, so what we have seen the static variable, these variables become active, then entire C program, they go on updating. Okay, so they go on updating means, so here I am incrementing the value of X by 1. Okay, so I'm performing again, go back to the main program. Here for loop is there. Okay, value of I is incrementing by 1. Now value of I becomes 2. Is 2 less than or equal to 3? Yes, condition is true. Again, I'm calling the function. So when I call the function, I'm going to display, okay, so x value will be incremented by 1 again. So it is going to display the 2. So similarly, till the condition is true, what is the value of I here? I less than or equal to 3. Maximum I can have 3 number. Okay. So is 3 less than or equal to 3? Yes. Okay. If that is the case, I'm going to print 3 as well. Now I will be incrementing by 1. So now I value become 4. Is 4 less than or equal to 3? No, condition fails. Okay. When condition fails, it is not going to execute the further part. Understood? So the output of this program is x is equal to 1, 2, 3. The last variable, that is register variable. Okay. So what is this register variable? These variables will occupy space from CPU's register instead of computer's primary memory, that is RAM. Okay. So it means that these variables occupy space where CPU's registers instead of computer's primary main memory. What is the primary memory of computer? RAM, that is random access memory. So these are defined inside or outside the function by using the keyword register. Okay. For static variable we use the static. Okay. For register variable we use the register. Okay. So these variables used to store frequently required data by processors so that the data stored in register can fetched in less time with a higher speed. Okay. So you know what is the importance of the register. So register, that variable, when we declared it as a register, okay, it can store frequently required data by processor so that data stored in register can be fetched in less time. This is one advantage. When you store in CPU memory and when you store in a register, this is a difference. When we store in a register, it can be fetched in a less time with higher speed. Okay, so that is why the cost of the register is more. Understood? Okay. Example for this is a header file will be there, void main register int I. Okay, so I have declared int I as a register. This is a register variable. So initially count is assigned to 0. Okay, so here I am reading this is a for loop. For I is equal to 1, I less than or equal to 100, and I plus plus. So initially count value is equal to 1. Now count plus plus. Okay, when I increment count by 1, the value becomes 1. Okay, again it will go back here. I is equal to 1, 1 less than or equal to 100. Yes, the condition is true. Okay, again incremented by 1 and it is going to print. So similarly, till where it is going to print? When 100 is less than or equal to 100, if this is the case, the condition is true, then it is going to print from 0 to 100 value. Understood? So this is a simple example for how we can declare register variable. Okay. So we'll see what are the important question you can expect from this particular concept. So here we have the first question. What is recursive function? Write recursive function to find factorial of n. So we have seen the definition of the recursive function, the uses of the recursive function, and one programming example on that is factorial n. Okay. The another question, that is discuss the following with example. Okay, it's about storage classes. So there are how many variables are there? 4 variables. Automatic variable, global variable, static variable, and register variable. Okay, so you have to explain all the 4 variables. Okay. Okay, I'd like to conclude this particular concept by just saying this quote: "The future belongs to those who believe in the beauty of their dreams," which is said by Eleanor Roosevelt. So thank you so much for patience listening. Thank you, one and all.